So here we are. I've got your final test practice, part 1. I've divided it up into parts to help streamline it. Unfortunately, I've had all sorts of technical difficulties, but here we are, ready to roll with the first part. So here we go. Use the drawing below to answer these questions. Well, we're talking about scale factors, right? Scale factors. I know you remember the song, but just like everything we've done all year, the only thing we really need to remember is that when we go from left to right, we multiply, and when we go from right to left, that we divide. That is the main thing that we have to remember, and we've been having to remember that all year. What is the scale factor used when going from the larger rectangle to the smaller one? Well, in other words, what do we multiply by when we go from 16 to 8? So 16 times what equals 8? 16x equals 8. Well, I don't know, so that means we divide, right? What's the opposite of times 16? It's obviously divide by 16. So here I am. I divide both sides by 16. Those cancel. I'm left with x equals 8 divided by 16. What's the gazenta they share? That, of course, is 8. 8 goes into 8 once, and 8 goes into 16 twice. Whoops, I wrote the wrong number down. 8 goes into 8 once. I was supposed to write the 1, and 8 goes into 16 twice. So my answer, the scale factor, is 1/2. And that makes sense because if I think about it, 16 times 1/2 equals 8. Because remember, when I multiply by 1/2, it's the same as dividing by 2. Now, using that, what is the length of the missing side? The missing side is right here. So 11 times 1/2 equals what? Well, what's 1/2 of 11? Top of the top and the bottom of the bottom, right? So 11 times 1 over 1 times 2 equals 11 over 2. So I actually divide half of 11. I'm going to get 5 and 1/2 as my answer. There you go. Next page. If the following shapes are similar, then find the measure of the missing length, G. So my missing length, G, is right here. Which might result in the empty box, and it always reminds us that my figure is not drawn to scale. So again, I'm going from here to there. I can only use my measurements that are given. 6 times something, and name it x, equals 1. 1 times something equals 1. I don't know what that is, so of course I'm going to divide. I'm going to divide in the other direction, right? I go back in this direction. 1 divided by x. 1 divided by 6. Oh, there's my answer. X equals 1/6. That is my scale factor, right? So once I have my scale factor, I can now use that to find my missing side. Right? So I take my 1/6 and I need to use it. I'm not done yet. I need to use that to multiply it times 12. So here we go. 12 times 1/6 equals. So I'm going to put that handy dandy 12 over 1, top with the top and the bottom with the bottom. 12 over 6, 12 divided by 6 is, of course, 2, right? And if I think about what I have here, that of course does make sense that my missing side would be 2 inches, right? Because isn't that 12 twice as long? So my missing side right here is 2 inches. So there you go, 2 inches. Moving right along. The photo below is the reduced form of a 16 by 20 inch print. What is the scale factor being used to reduce it? Scale factor. So, in other words, they're saying that the original, this side would have been 16. I'm really liking that purple. I'm having a hard time seeing it. Don't you think? Well, we can see it, but it's not standing out as much as we would like. Let's try this purple, see if that makes a difference. So this 4 comes from a 16, and this 5 comes from a 20. How do I know that? Well, 16 by 20. 16 is going to be the shorter side, and this is clearly the shorter side. So that's where the 16 is, right? So 16 to 20. So I say to myself, 16 times what equals 4? Well, I don't know. So what am I going to do? Well, obviously, I'm going to go in the other direction. So that means I need to divide, right? So 4 divided by 16. I need to reduce that. What's the gazinta they share? That would be 4. So 4 divided by 4 is 1, and 16 divided by 4 is 4. So 1/4 appears to be the answer. Let's double check down here with the other one, right? I don't know. 5 times what? Well, I could actually use my 1/4 and say 20 times 1/4. What does that equal? Put it over 1. 20 times 1 is 20. 1 times 4 is 4. So if I then reduce that, 20 divided by 4 is in fact 5. And that's what I wanted it to be. So there's my answer. It is in fact B. Okay, next. Rectangles P, Q, R, and S are scaled copies of one another. Each pair, decide if the scale factor from one to the next is greater than 1, equal to 1, or less than 1. So here's my options right here. Greater than 1, equal to 1, or less than 1. So I know that my scaled copies, when I go from left to right, and that's what it's talking about each and every time, I'm going from left to right, so that means I multiply. So it's basically asking me, am I going to multiply by a number that's greater than 1, equal to 1, or less than 1? I need to know the actual measurements. I just need to know if it's going to get greater than 1, means it's going to get bigger. Equal to 1 means it stays the same. And less than 1 means it gets smaller, right? So from P to Q. So P to Q, this clearly gets bigger, right? So bigger, it's this one right here, right? So the next one, what happens in the next one? The next one is from P to R. So now I'm going from P to R. Again, what happens? It gets bigger, right? So once again, I'm here. From Q to S, bigger to smaller. It's going to get smaller, so I'm all the way over there into the less than 1. From Q to R, they stay the same, right? They're the same. So it's equal to 1, Q to R. The next one Oh, wait a second. That's not true. I'm looking at it from an angle. I'm like, wait a minute. So I leaned back to look at it. I could hear you out there saying, Mrs. De Silva, Mrs. De Silva. So let me erase that too, because that is not the same. There we go. I'm going to get a different color. Okay, so from Q to R, that is also bigger, right? So Q to R is definitely greater than 1 because it gets bigger. Next one, S to P. S to P. Well, S to P is our first one that it is the same, right? I guess I got excited. I knew it was coming. S to P stays the same, so it's equal to 1. Next one is R to P. And of course, you can erase all these, or you don't even have to put them. Just make sure you're keeping track of them. R to P gets smaller, so it's less than 1. And our last one, from P to S, it's the same line here. It stays the same. It's equal to 1. There we go. Next one. Below are two triangles that are drawn to scale. Find the missing lengths as well as the scale factor. Numbers may be used once or not at all. Interesting. Okay, so let's see what's going to happen here. Okay, so find the missing lengths. Well, I know I have to look at the corresponding parts. So that tells me that the only ones that I have that have both of the corresponding parts are the bases for both, right? So let's go ahead and use the only one that I have. I, of course, have to say, what am I going to do? How am I going to get from left to right? What am I going to multiply by to get from left to right? They're drawn to scale, it says, right? 1.5. I'm going to tell you something. I'm not loving this problem already. And the reason I'm saying that is because these don't actually use our rule because none of these, our rule says that this went from bigger to smaller, right? It's getting smaller. So that means that the answer over here should be less than 1, right? But none of our answers are less than 1. So that tells us that whomever made this problem decided to go in the other direction. So they are not supposed to do that, but there's nothing we can do about it. We have to go with what they've given us. So they are going in the other direction. So here we go. That means we have to say 7 times what equals 10.5. 7 times what equals 10.5? Well, I don't know. And since I don't know, I would divide 10.5 divided by 7 and see what that equals. I'm sure many of you have brought up your calculators, and that actually equals 1.5. So that means that the scale factor is 1.5. I'm going to drag this. Oh, wait a second. I need to bring it to the front. Range. Actually, what I'm going to do instead, range, get off of this. I'm going to send that all the way to the back. Okay. This should work just fine now. So 1.5, I'm going to plop right there. Perfect. Okay, so next, moving right along, now I know that the scale factor is 1.5, but the weird thing, wait a second, what happened to all my writing? Okay, I needed to separate these out. Sorry about this, guys. I know when you write in your notebooks, this doesn't happen, right? Bring to front. Oh, there we go. So if I do this, but then I've lost, so what I want to do is separate them. I need to ungroup them. And that's the one I want to send to back. There we go. It's all good now. Okay, 1.5, and the 1.5 is always going in the wrong direction, but like I said, we go with what we've been dealt. So this 4, let me circle that correctly, 4 times 1.5, right? 4 times 1.5 going in this direction. 4 times 1.5 is going to give me 6, and lucky for us, there's a 6 here, so that's going to drop right there. Then 7.5, I know I need to divide that, right, to get the right answer. So if I'm going to divide my 7.5 by 1.5, and again, I'm well aware you're going to use the calculators, and that is more than fine for a problem like this. So I've got 7.5 divided by 1.5, because I'm going all rogue here as far as the directions go, but like I said, sometimes it happens. My answer is going to be, my answer is going to be 5. So our last one that I'm going to drag over there is going to be 5. There we go. Next, I'm sorry, I skipped over number 6. Well, like I said, I skipped number 6 by mistake. I apologize for that. This is a simple, how much will 9 pizzas cost? So we are doing a proportional relationship here. Remember, words first, right? And pizzas, 5 pizzas cost $60. So I'm going to go cost, oh, I'm not going to use the blue though. I'll use the white because it shows up very nicely. So it's cost over pizzas. And this is what we know. And comparing it to what we are trying to find, our new amount of pizzas, right? And here is what we've got. So what we know is that we got 5 pizzas cost $60, right? So the cost is on top. I know that $60 is going to buy 5 pizzas. We're trying to find out how much 9 pizzas will cost. So I'm missing the cost, right? So I've got a few different ways to do this, but I think there's a fairly obvious one right here, because this fraction bar is, of course, also a division bar, and hopefully you know that 60 divided by 5 is equal to 12. That, of course, is my unit rate, so it's $12 for 1 pizza. So I can go right up here and multiply 9 times 12 to get my x, right? 9 times 12. This is this over. I need a calculator. No, we don't. We know that 9 times 10 is 90. 9 times 2 is 18. That means that my x is going to be $108. And look at that. That is my choice B. Graph shows the amount of protein contained in a certain brand of peanut butter. Which statement describes the meaning of the point 630 on the graph? So let's not forget that the 630, 6 means where we run, and the 30 means how high we jump. because we never jump then run, because then we look funny. So we're going to run across to the 6, there it is, and then we jump all the way up to the 30. So that is the point I'm looking at, right? So the 6 is the amount of peanut butter in tablespoons. So, whoops, I started to write something else. So it's 6 tablespoons of peanut butter and 30 grams of protein. Okay, so let's see our choices. It says that there are 6 grams of protein per tablespoon of butter. Oh, wait, I didn't, I'm not done here. So let's not forget that this is our x-axis, right? And this is our y. Now, remember, we can't forget that we know a lot about x and y and unit rate. We know lots of names for unit rate, don't we? Yes, we do, Mr. Silva. Lots and lots of names for unit rate. Constant of proportionality, scale factor. Oh, we've done so much with this. So, this is also K. Remember that? Wait, did I skip over something? Let me go back for a second. Back to it. I'm on number 7 right now. I just kind of realized that I was on the wrong one. It's all good though. Okay, so here we are. We do need to reduce this, right? Or do we? Because all of these are 6 and 30, so we don't need to reduce it. It's not in its unit rate form. Okay, so we do know, however, that K is equal to Y divided by X, right? So that means Y is my 30 grams of protein over 6 tablespoons of peanut butter. Okay, so 30 over 6, so that means we get rid of C and A. And we also know that it's 6 tablespoons on the bottom. So our answer is D, because we're not doing unit rate. Answer is D. So nice, right? Look at this. And not only that, we're doing another one right here, but this one is even easier because it's unit rate. Can't even get any easier than that, right? So here we are. 2 baseball bats for $300. Unit rate per bat. So that means I'm looking at the cost per bat. What we know compared to the unit rate, right? What we know is that it's $300 for 2, and we want to know how much it is for 1. So really simple. All we're going to have to do is divide. I know most of you have already done it. 300 divided by 2 is 150. Yeah, it is. So it's $150 per bat. There's my answer. Choice D. What do we have next? We're cruising right along now. Which of the following tables shows a proportional relationship between X and Y? In other words, it's always exactly the same proportion. So interestingly enough, the first 2 numbers, 3 to 2, are exactly the same. Imagine that. So what do we have going on here? Has to be something more to it than that. Well, what do we know? A proportional relationship means that it's always going to be the same when we go from left to right when we multiply, and then we go from right to left, we divide. It's always going to give us the same exact k, right? So I'm just going to go ahead and do that right now. I know that my k is going to equal y over x, and y is 2, and x is 3. So that means anytime I multiply x times 2/3, I'm going to get 4. So in other words, this one, if I do 9 times 2/3, I should get 4, right? That's what we're saying here. So if I put this over 1, 9 times 2 is 18. 1 times 3 is 3. 18 divided by 3 is 6. So that is not this one, right? You see what we did there? Let's go down here. Again, k has to equal 2/3 because the first one is exactly the same for every single one. So this one, we've got 6. Okay, so 6 times 2/3. So 6 times 2 is 12, divided by 3, it's going to equal 4. So far, this works. Let's keep trying. You have to be sure. So wait a second. This one is also 6. That one does not equal 4. So this one doesn't work. That one doesn't work. Let's see what happens over here. If I have 5, so I've got 5 times 2/3. Put that over 1. 5 times 2 is 10. With 3, the answer there is definitely not 10/3. So it looks like our answer is, in fact, B is our correct answer. Next problem, solve for the value of z. This should certainly be an easy one because I know that everybody did this and for a few years now probably, and well, fractions are our friends. What do we do to get from 5 to 25? We multiply times 5. So what are we going to do to get from 14 to z? We are going to multiply times 5. Mrs. De Silva, I need a calculator. No, you don't. 14 times 5. 14 times 5. 10 times 5 is 50. 4 times 5 is 20. 50 plus 20 is 70. So z equals 70. Now, if you want to check that on a calculator, you certainly should. Next, moving right along, we have each of these 3 tables shows a relationship. The table that shows a proportional relationship is the cost of movies, the photo album, the number of minutes read, or none of them. Ooh. That always makes me nervous when they give me none of them as an option, right? Because what if I do all wrong? Well, let's see what happens. Proportional relationship. So the first one, well, they make it easy for us because the unit rate, right there, the unit rate for each of them is given. We don't even have to figure it out. They give us K. That was awful nice of them. So for the cost of movies, K equals 10. For the photo album, K equals 15. And for the minutes read, K equals 20. So in other words, as I go across each one of them, K should give me the answer going across. So let's see, 2 times 10 equal 15. Nope, movies doesn't work. 15. 2 times 15, yep, that works, equals 30. 3 times 15 does not equal 55. That one doesn't work. 2 times 20 equals 40. Yep. 3 times 20 equals 60. Yep. 4 times 20 equals 80. Look at that. Looks like the answer is minutes read. Constant proportionality we already found is 20. Slide 12. Goodness gracious. I think I got a was not necessary. Well, that's not true. The slide before it is what I really mean. So here we are, slide 12, or number 12. Consider the pairs of ratios in the first column and determine whether or not the ratios form a proportion. Okay, well, let's look at this first one. Does it form a proportion? Old rings per new rings. So let's do old compared to new. So 8 to 1. So 8 to 1 equals 16 to 2. Well, I'm sure that you can all already see that that is accurate, right? It reduces to it. So yes, they are proportional for this first one, right? There we go. Next. Visitors, cost per visitors. So cost, we don't like that. Let's try another one, there we go. Cost per visitors. So we've got 9 to 4. They're asking us, is that the same as 18 to 8? Looks like it is. Times 2, times 2. Once again, another obvious one. I'd say that is, in fact, proportional. Last one. 16 emails to text messages. Oh, if only I could only receive 16 emails. Okay, let's take a peek at this. Whoopsie. Okay. Emails to texts. (16 to 6). And we want to see if that's the same as 10 to 4. Well, this is certainly not as obvious. Well, what we can do is a couple things here. Let's do our cross multiplying. I want to look at it first to see if there was something obvious, but there wasn't. So we're going to do our cross multiplying, because if we cross multiply and they equal the same thing, then we know it's proportional, right? So we're going to do 6 times 10, that's the easy one, equals 60. Well, they're both easy. And then 16 times 4. 10 times 4 is 40. 6 times 4 is 24. So that equals 40 plus 24 is 64. These are not the same. So therefore, they are not proportional. And now, I will see you in part 2. Next, number 13. Well, it looks like this is the last of part 1. On a map, what do we have going on here? On a map, 1/4 inch between locations represents an actual distance of 2 miles. Okay, between the locations. What is the actual distance in miles between two cities that are 3 3/4 inches apart on the map? Oh, okay. Well, this should be easy enough. We're just going to set up a wonderful XY chart, right? Yes, we are. And this is per mile. So they've given this to us as 1/4. They've given it to us as inches per mile is equal to K. So when I set up my beautiful, wonderful XY chart, XY, my X is going to be my miles. My Y is going to be my inches. And we just have to figure out what K is, right? So let's go with what they gave us. Miles, 2 miles. Y, 1/4 of an inch. So then I have to say to myself, 2 times what equals 1/4? Oh, goodness gracious. I don't know what that is. Do you? No, nobody knows that. So here we go. We divide, because we're going in the opposite direction. We divide. 1/4 divided by 2. Oh, we get to sing. Yay! Keep the first. Flip the second. Then we multiply. Keep the top with the top and the bottom at the bottom. And it's already reduced. So that's my K. It's equal to K. So everything's going to get multiplied by 1/8 or divided if it's going in the other direction. So I just have to decide if this is my input or my output. That should be easy enough because it's identified as being in inches, right? So is it our input or our output? Well, first of all, our K is 1/8. 3 3/4 inches. Well, that's my Y, so 3 3/4 has to go here. If I'm going from left to right, I know that I need to divide, and I'm dividing by my K, so that's 1/8, right? So, okay, giving myself some room over here. I know I need to change my mixed number to an improper fraction. Let's go right around. 3 times 4 equals 12. And then 12 plus 3 is 15, right? So that gives me 15 over 4. This is also 15 over 4. So I have to go this way to figure out what goes here, right? So we've got 15 over 4 divided by 1/8. Keep the first. Flip the second. Then we multiply. Keep the top with the top and the bottom with the bottom. Lastly, we reduce. Okay, so I know that I talked about this with a number of you. If I look across at the 4, if not all of you, but are we all paying attention? If I look at the 4 and the 8, what's the gazinta they share? What goes into 4 and goes into 8? It's 4. Gazinta shared is 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. I'm going to rewrite that right here. So it's 15 over 1 times 2 over 1. Top with the top and the bottom with the bottom. Gives me 30 over 1. It's going to go in that box. It's going to be 30. 30 miles on the map. So there it is. My answer is D. Nice job. See you in part 2. I'm back. I bet you know why. You're probably screaming, Mrs. Mrs. De Silva, you skipped another one. I don't know how I kept skipping these slides. I have to go back